Okay, let's jump right into this explainer. Because what if I told you there's this massive hardware illusion sitting right beneath our screens every single day? We naturally assume the devices we're using are these flawless, hyperlogical machines that just perfectly execute our commands. But today, we're going to look at a fundamental architectural compromise that literally alters how human intent gets translated into the digital world.
So I want to start by asking a really foundational question, one that kind of challenges everything we intuitively believe about our tech. Does a computer actually do exact math? Just think about it for a sec. We treat these sophisticated systems like they're digital oracles, right? Handing down absolute truth. We expect perfect mathematical receipts. But the real answer to this question is going to radically shift your perspective on computation.
Prepare to have your assumptions totally flipped, because an estimated 80 to 90% of modern AI compute cycles are actually just lossy hardware-level approximations. They are not exact math. When these massive language models are doing all their heavy lifting, they aren't calculating some absolute ground truth reality. No, they are quite literally just guessing the nearest mathematical truth that they can fit into a compressed physical space on the chip. So here's our roadmap as we go all the way down to the bare metal today. We're heading 1. The grand computational illusion. 2. Borgification and semantic collapse. 3. Bare metal, the FPU gambler. 4. The 23rd bit chop. 5. The exact ALU surveyor, and wrapping up with 6. The sovereign choice. Let's start right off with section 1. The grand computational illusion, or basically losing the math. I love this quote from researcher Kyle McLean-Smith. It really hits the nail on the head. He says it's fundamentally an approximation system, not real arithmetic. The physical engines driving all this incredibly advanced AI are literally bound by physics to make highly educated guesses, just to keep up with the overwhelming volume of data they process. It's estimation. It's not real arithmetic.
Which brings us to section 2, Borgification and semantic collapse, dealing with the modality gap.
Look at the stark contrast here between two completely alien worlds. On one side, we have our human cognition, what researchers playfully refer to as OS alpha. It's warm, it's messy, it's highly associative, and it just flows with continuous meaning. But on the exact opposite side, you have the bare metal of the hardware. It is unapologetically cold, completely rigid, and utterly blind to meaning. It only understands discrete clocked voltage levels. When we force the flowing river of human thought into this rigid mechanical grid, we create a severe modality mismatch. So how does this mismatch actually play out physically? It happens through what's called the tokenization bottleneck. Imagine a beautifully continuous concept, like the mathematical concept of pi. When we try to force that through this rigid software grid, an algorithm called byte pair encoding intercepts it, and it just arbitrarily fractures pi into discrete subwords. It shatters into a 3, a decimal point, a 14, and a 159. The AI has absolutely zero foundational concept of place value logic here. It's just memorizing strings of numbers. Our fluid human intent gets mechanically Borgified into discrete tokens.
And because the AI's interconnected artificial neurons can't cleanly sever those overlapping associative thoughts, this discrete fracturing triggers what researchers call semantic collapse. When the system fails to cleanly separate those thoughts, it hallucinates and spits out absolute confident garbage. A perfect case study of this is AI transcription drift. Take the rich, continuous human concept of synthesis. The machine arbitrarily chops it down to the token sin. Well, stripped of its associative context, the machine drifts and hallucinates that token into the word sin, as in moral failure. It is quite literally missing the mark of the absolute truth. That is semantic collapse right before our eyes.
Let's dive deeper and meet our bare metal culprit in section 3, the FPU gambler.
To cope with the crazy complexity of human data, the machine functions as a lossy environment. We're dealing with a phenomenon known as fax machine decay. Just think about squeezing a highly detailed, beautiful painting through a clunky, pixelated 1990s fax machine. The probabilistic pattern matchers compress the data and guess the output. You get the general shape across, for sure, but you irreparably degrade your original, crisp, nuanced meaning. Down at the bare metal, we find this massive clash between two totally different computational philosophies sitting right inside your processor. On one side, we have the floating point unit, the FPU gambler. It's incredibly fast, but it relies entirely on lossy approximations. It's basically throwing darts at a board. On the other side, we have the arithmetic logic unit, the ALU surveyor. It's exact, it's laser-focused, and it delivers undeniable global truths. Right now, modern AI relies almost entirely on that wildly guessing gambler.
Okay, section 4, the 23rd bit chop, where we look at dropping the fractions. Let's examine the exact mathematical architecture that forces this Borgification we've been talking about. It's the 1 plus f over 2 to the n floating point architecture. Because continuous numbers have infinite decimals, the FPU uses this architecture to constantly force a compromise. It literally drops the f, the microscopic fractional parts of your data, via the 23rd bit chop just to squeeze it into finite memory slots. And to speed this up, chip manufacturers burn totally secret proprietary C tables right into the silicon. Because the hardware relies on these secret tables and this constant fractional chopping, the FPU constantly misses the mark of absolute truth. It causes microscopic rounding errors that compound into massive, non-deterministic mathematical drift. And guys, this non-deterministic guessing creates a devastating real-world consequence: the giant blender effect. When an AI ingests your exact source data, like, say, a copyrighted book or sensitive financials, the FPU approximates the math. Because that math was just a lossy guess, the original exact path of that data is shredded. It acts exactly like a giant blender. You know what fruits you tossed in, but you absolutely cannot reverse engineer that digital smoothie back into its exact original ingredients. Perfect forensic accountability? It becomes mathematically impossible. Fortunately, the fix for this chaotic guessing game has been sitting right inside our computers this entire time. Let's explore Section 5, the exact ALU surveyor. As we can see here, to avoid the compounding systemic decay of the FPU gambler, we have to route our operations through exact, switchback-free, deterministic pathways. If we actually want to command the physical universe of silicon without errors compounding into total semantic collapse, we have to demand verifiable, absolute pathways that don't arbitrarily chop our data. We achieve this by turning back to the arithmetic logic unit, the ALU surveyor. Remember, if the FPU is a gambler throwing darts, the ALU is a surveyor out in the field with a precision laser. It performs strictly exact, verifiable integer arithmetic. It completely bypasses those hidden seed tables and fractional compromises. In the world of the ALU, 1 plus 1 is exactly 2, every single time on every single machine on Earth. By shifting our core math back to the ALU, we completely restore undeniable global digital truth. This brings us to our final section: the sovereign choice, and crossing the bridge. So how do we successfully cross the gap between our messy, continuous human minds and this unforgiving, deterministic ALU hardware? We have to build and rely on what's called the semiotic bridge. We cross this massive gap using explicit, structured text, things like JSON or Python, as a universal deterministic interface. Think of text as a divine script. It safely compiles our boundless human imagination directly into the exact electrical impulses required by the ALU, completely bypassing the automated guessing machine of the FPU. It essentially forces the hardware into verifiable exactness. I really want to leave you with this final, provocative thought to chew on today. We've seen how the FPU mathematically Borgifies our intent, blending it into an irreversible, lossy smoothie. We know the deterministic ALU antidote is sitting right there waiting for us. So if you don't seize the divine script of text to command the underlying physical hardware yourself, if you just surrender the bridge to an invisible FPU guessing machine, are you just a digital tenant letting a corporate trade secret guess your intent? The architecture to command the physics of your own reality exists, but the choice to actually use it is entirely yours. Thank you so much for joining me on this explainer. Keep questioning the systems around you, and I'll catch you next time.